Oh my gosh, I feel like Krusty the Clown. I was trying for that one today. That was a good one. Usually whenever these streams start, I feel like Krusty the Clown, like at the beginning of the Simpsons shows when Krusty comes on, he goes hi hi, and he's just all of a sudden obnoxious, and that's how I feel on this when the little green light comes on right there. So hey, I'm Tom, Lift and Shift Foundation. What else do I need to say? I feel like if there's anybody watching, you already know who this is and what we're doing. But I'm gonna do it anyway. I'm gonna get into a little bit of the Lift and Shift Foundation. We like to encourage veterans, to find a place in science and technology, and do a lot of things to promote that in front of and off of behind the camera. So one of the things we do is this Battle of the Bots thing, and it's actually really kind of fun. I'm not gonna dwell on too much. Come back, follow us. Come here on Saturday afternoon, and you can see it for yourself. We also do it in person. We're trying to get that restarted. It's been a challenge because of there's this crazy virus out there trying to kill everyone. So it hasn't been happening in person for a while, but we're looking at restarting it anyway. I'm gonna get into this. I usually spend 45 minutes, sometimes an hour, with some kind of project, some kind of science type thing that we happen to be doing here behind the scenes. Usually, it involves a design team that is participating with me, but not here on the camera. So this is my turn to kind of hoard the limelight, which I'm not really too big a fan of. But we're a small Twitch account, and that means that I can't invite a team, and I can't share hosting as easily as some of the bigger accounts. So we actually just met earlier, our design team. We hooked up hour or so earlier, and chat, do some things, connect on some of the projects. I'm gonna spend, I don't know, half hour today sharing some of the stuff we did and recapping a few hacks and mods we've done for this robot we're gonna fight on Saturday. I'm excited. I'm pumped, and I hope you can hear me. I gotta make sure that the microphone is on, because I've had that problem before. There we go. I see it. I see the little line going back and forth like this, so I'm pretty sure somebody can hear me. And I'm gonna get into like the techie nerd stuff, and point at that thing right up there and just say I've changed some hotkeys this week, so I think things will work a little better for me production wise. But one of the things we did today was open packages from SaneSmart, who's a company that gave us a bunch of products to review, and these things are awesome. I just want to take like 5 minutes to say thank you for sending us this ultrasonic sensor that we'll be jamming on a robot sometime soon. In fact, it looks a lot like that thing right up there, right? It kind of looks the same. Dun dun dun. There it is. It looks the same. Got this dot matrix kind of screen that we plan on incorporating into our robot design plan, and we got this. I'm just gonna plug it in real quick, just because this was fun to unbox and take apart today, and I've made the plug childproof. There it is. So it's got this crazy thing, and I'm going to turn it off right there because that feels like a seizure. I don't need anybody going crazy or doing anything unnecessary with that, but I'm going to take that away. We're going to come back, and I'm just going to say thank you to SaneSmart, and we had some fun today chatting through options, ways we can add this to the robots and or the arena, and how we're gonna take advantage of the generosity that SaneSmart's given to us by sharing a bunch of products for us to review and to play with and add to our arena, and all the things that come along with having cool gadgets. I'll also say that the Lift and Shift Foundation is a nonprofit, so we appreciate it, and if there's any way for them to claim it as a donation, that's awesome for them. And the same would go for anybody who wants to give us something. Hint, hint, nudge, nudge. While you're out there, if anybody who catches this We are happy to share stuff and write stuff up and then use your tech and your gear and your products. And I'm probably your worst product tester because I'm an engineer and I was in the Army, so I will no doubt break your stuff in the process. But at least I'll tell you where it broke and how to fix it. Thanks. Cool. All right. So now that I've done that, we've gotten away from that process. Back to our project. There'll be more about that now, but because we have some ongoing things that have happened here in the last few weeks, and I just wanted to give the shout out, say thank you to SaintSmart first before we got into anything else, because this happened over the weekend, and I've been juggling a lot of parts and pieces and things in the background. And I'm super psyched about it, but I'm here with our Ranger robot. Dun, dun, dun. Here he is. And more important, here is the big guy right here. He's out. He's loose. I'm going to set him here. I'm gonna crash the screen. And honestly, the important part here is this eye sensor. We've designed a few parts already, and I'm gonna go over some of the bits and pieces, because my favorite part here is actually the battery mount. And if I turn him around, you can see the battery mount. The battery mount moved the battery box from under this control module to the back, and that's going to be a blast. As far as an addition to the robot arenas and the things that we're doing, and I hope people get to see how big an improvement that is on Saturday, because that is honestly going to be a lot of fun. Now that the batteries aren't slowing us down, or the battery changes, I should say. But now what we want to do is try to eliminate something that happens in our robot battles, is that the robots get caught on the eyes. This is the ultrasonic sensor, and the robots get caught on this. You can see right here as I do this, you can see the robot, if the robots run into each other and they start crawling up their tank treads, they get caught right here on the eyes, and they'll get locked together. They won't go anywhere, and we'll occasionally call it a draw. Or try to start the match over. Sometimes they struggle and they get out, and I want to come back and just explain this, that the locking together is not necessarily a bad thing. The locking together means we can solve it two ways. We can solve it through code, which we will get up to. We will eventually start doing, but the goal here was not to make the coding extremely challenging, because we want newcomers to show up and not feel intimidated that we are the experts on these robots, and that we can code like Wally and all of these other things that you see. So the idea is to keep the code simple, and instead create some kind of hardware to stop the catching of parts together. So our first big project between the advanced coding and the adding of hacks and mods for a robot is actually building something on the robot's face to kind of solve the problem of them catching and getting locked together. So honestly, I'm going to take a step back, and I'm going to go through some of the steps where the robots lock, and one of them will eventually climb the other one, and they get locked like that. So there are ways we could solve that. And as a design team, actually a few weeks ago, we were discussing this already. The robot has a sensor. This robot, as I take it away and bring it back up here, this robot has a gyroscopic sensor, so it can sense directions and turns and things. So it's in the middle here. It can detect on an X and a Y and a Z axis. So one solution in a software would be to code the robot so that when it gets locked in a position like this, it changes its tactic and does something else. And that's a solution. That's definitely an option. We want to consider that, and that gets us into more advanced coding. And we've decided as a group. Here, I'm going to put the robot back. We've kind of decided as a group that we're going to structure our Battle of the Bots events, challenges, and things, especially for the live stream. We're going to structure them in a way that there's a yellow belt or a green belt or a that introductory kind of player. If you're looking at difficulty levels, like when I played, I don't know, like Legend of Zelda, I could pick like easy, medium, or hard. So we're looking at that same kind of idea that if my kids or Dave's kids or Joe Snuffy brings his kids onto a live stream to code a robot and fight them, we want that introductory, that easy level, because that's going to give them a way to get in and get involved and not just get their butt whooped around. So it'll make it more fun. And the kind of coding that we're talking about, where we're taking advantage of other sensors inside, is advanced. That kind of starts to create a medium difficulty or hard difficulty or oh my gosh, what games there was? I'm sure there were other games out there like Metroid was extra hard and don't even try it, stuff like that. But the goal here was to create a match and an event and a challenge that was fun, that wasn't boring. It wasn't just two robots locked together like this and us staring at it, but not to make the coding too hard and too complex or nobody able to follow along with what we're trying to do. So this is actually us developing kind of like more guardrails to make the gameplay easier without adding to the complexity for the players. So you will literally snap together blocks just like Legos, and we'll get into all that on Saturday. It's not very complicated. It's not very hard. We don't have to learn any code or do anything else. And this means we use even less code by building some hardware on these. And of course, I when I think about like hacks and mods for the robot, I want to put on like spiked wheels and laser beams on his head and shoot stuff. All the cool fun stuff that goes along with evil geniuses and everything else. But we're not there yet. We're with this basic robot. So the fun part is going to be building some kind of face shield or guard on this set of eyes that sticks out. You can see it here. I'm going to show you. It sticks out right here, and check it out. So these parts stick out right here, and that board that you saw catches it. So we're gonna continue the project we started last week, and we're gonna work on something that comes up right here and stops those from catching. And so I'm gonna leave this part right there. We're gonna come back to it every now and again, but I'm gonna hop right into Tinkercad because this is where we did our work last week. And as I hop right into Tinkercad, here we go. I am gone. Hopefully I'm gone for the rest of the night because I'm a hot mess and nobody really needs to pay attention to me. But I'm going to shift some screens around right here so I don't have to stare at this, so I don't have to stare blindly away from the camera. And now you can see I'm actually staring at the camera because the camera's right in my face. But back to this model here in Tinkercad. Last week we redesigned this thing right here. There we go. So this looks just like that part right there in Tinkercad, and now we as a design team we've had some discussions about how to stop this from happening. I'm going to do something quick here. I'm going to turn this up so that it looks the same way that it would look for as it were attached to our robot, which is just like that. So I'm gonna do the quick reveal and say, here we go. Here's Dave's suggestion. Dave over the weekend with our design team scrolled through a lot of the parts here in Tinkercad, all these things and all the stuff over here, and he was looking for something that would fit and be entertaining and fun, and he came across this football face mask. And look, check that out. It's almost like an exact fit for this mask. So So that is kind of cool and crazy, and I dig it. I'm kind of happy about it. We wondered how it gets attached, and I'm just going to quickly look at it right here and say, if it's right there, it probably would pull up to his face or hit the eyes, like hit the eye parts like right there. You can see where it's kind of overlapping on the eye parts right. I'm gonna use this as a pointer today, and this is something I have been thinking about, but I'm gonna use this as a pointer. So you can see like right there at the end of my pointer, it's kind of hitting the eye socket thing. So we would probably have to pull this back a little bit like that. Maybe that's a little more centered. In fact, I can line this up. We can use the align feature and actually center it so they look centered. And now you can see that it's not really catching anything all around. So what we would probably do is here on the back, like right here, slip a zip tie between here and there around the back to hold this thing on. So a zip tie would probably go across here like that, and it would grab this post like that and go around the back and hold the mask on. And I think that's kind of cool. That's kind of, it gives. Let me pull up my pointer out of the way here. This is super funny, right? But I look, it gives our robot, a personality now. It makes our robot cool. It makes things feel more human, so to say. But from a functional kind of like view, the end of the mask here kind of sticks out a little bit, right? So you see this, there's this angle where the mask seems to stick out. So if I grab my pointer and I come back, no pointer. Oh my gosh, never mind. Go away, pointer. Let's just get a new pointer. Let's try this again with a new pointer. In fact, let's make it a pointy pointer. Dun dun dun. Let's do 10 and 10 and make it a fun pointy pointer. Yes, there we go. Oh my gosh, I'm gonna have so much fun. So, yeah. No, you are good. The mask works. I'm just pointing out a little bit of geometry. So, this mask is flat on the bottom here on the workspace, and it's something we were talking about earlier when we were talking about like how do we 3D print this mask. But notice that the mask actually protrudes from the face here much further. So we in the way it's sitting on our workspace right now, it's actually gonna catch more of our robot, of our opponent. So there's potential for this mask to create a bigger obstacle, is how I'll put it. And because this comes out, let's see, if I do this math, if I drag this over, you can see that it actually sticks out like 3 centimeters further from here to 28 millimeters. These are the grid here is in millimeters, so 28 millimeters is 3 centimeters or so. But that honestly, that is not a problem, because here in Tinkercad, I'm gonna do this very easy. I'm just gonna turn this like this. So check it out. So if we turn the face mask so that it looks more like it's attached to a helmet, like that, then we back it up. Now, right there. We got it, dude. So if we shift the mask so that it's at an angle, now all of a sudden the bottom here isn't sticking. We have to lift the bottom up. It may not fit the same eyes. Like you can see, like it looks like he's angry right now. Like the top here looks like a brow, like an angry brow. If I lift my pointer up here, the top right here looks like an angry brow now, right? Oh. Yeah, that thing right there looks like an angry brow, yeah. But down at the bottom it's doing something different because there's this angle. There's this angle right here at the bottom where it's actually the bottom of the face mask here is sliding under the eyes, and it's creating this like ramp. And we can move this a little further. So it's starting to look more like the top here is flat, and that's kind of where we want the top to be a little more flat. It looks almost like a lacrosse helmet like this. Sometimes the lacrosse helmets, the face guard comes down and like holds closer to the jawline. So this actually makes a lot more sense, and I dig this model if we tilt it to an angle like this, and if we tilt it far enough, ooh, like that's too far, but like that right there, now all of a sudden we've got this really cool looking mask, and we just have to get it on the right angle, and it looks like it'll fit. There are points in here where it will fit around the eyes. So if I draw my pointer back out here again, we can check out like right here. It looks like these are good spots around the eyes. And right here, along the plate, oop, I'll lift this up and down. It looks like right here, this could fit just like that, and we could still use a zip tie as a quick solution to hold this face mask on. And that means that it's possible we could modify the face mask, the top part of the face mask. We could, for example, cut it off. Do like this right here. Cut it off flat with the top of the the helmet or the eyes, and come up with a better way, an easier way for us to print this. Come up with a flat surface so that this will print on a 3D print bed, and we'll have a little more surface to it here, and a you know, something flat on the workspace so that we could do this. So I dig this, and this is definitely, like, this is gonna happen. I don't know if I have enough time to do the quick modifications and get one printed for Saturday. I will do my best tonight and tomorrow to do that, to print. But we checked this out earlier, and this is we put this in a slicer. We put this in Cura. We rotated it around and tried various settings with the support structures and things. It looks like it's going to take hours to print, just as it is. So my goal would be to get it down to, you know, like an hour and a half print. That way we can maybe try a different, or try two different versions and see which one's going to print, which one I'm going to have problems sticking to the bed. Maybe have to do a brim or a raft or something. For the 3D print nerds out there who are with me, I'm just gonna say some of this stuff, quickly. But yeah, so this is like a wireframe kind of structure, and a lot of times the 3D print bed is a flat thing, and your piece has to stick to it. Like for example, I print this dog tag in a work group with or a workshop with Wounded Warrior Project, and you can't print this dog tag flat up like this because only this little tiny part is touching the printer bed. It's not sticking. It's going to go flying off everywhere when the printer nozzle moves around. So we have to print it flat, and then it has this entire surface to stick to the bottom of the print bed. So that's how you design your parts so that they are capable of being 3D printed. And here we go back to this model right here, you can see it's a wireframe. It's just this like gray frame. So I love it. I think it's awesome. It's going to be cool, and it's going to be one of just like a bunch of things that go on these robots. So it's going to be fun to make and build and print and stick on the robot and then show it off and say, look what Dave did. It's cool. So I dig this part, and we're probably gonna take a week, or between February and March is Battle of the Bots. We will take some time to make this look presentable. I don't want to jam it through a bunch of quick prints and have something creepy looking that doesn't look anything like this on the robot, and try to tell people no that's really the helmet that or the face mask that Dave picked. I'm just a bad 3D printer. So this is I dig this one. I love it, and I'm gonna erase the block here. I'm gonna take the mask, and I'm gonna keep it in this work plane, because this is our workspace for hacks for this robot. So I'm gonna keep it over here. Maybe not. Undo. I'm gonna grab the robot, or I'm gonna grab the face mask. It's even hard to grab because it's like a wireframe thing. I'm gonna push it to the side for a minute, because I'm gonna do a quick. I've gone through, I don't know, 25 half hour. I'm gonna do a quick model of a beak. There was this idea that I threw out last week, but I was running out of time and I didn't wanna get too much into it. So this idea I had last week was to create a beak on this robot's face, and I kind of want something that looks like a pyramid. I ran out of time, so I just kind of like quickly showed the shape and said here's what it could look like. Here's the modeling. But now I have I don't know, 20 minutes, 40 minutes, or 20 minutes, half hour excuse me, to talk through this design and how easy and how quick this will be to do right here in Tinkercad. So what I'm going to do is I'm going to go back into Tinkercad. I'm going to move some stuff around. Here we go. We're just going to hop right into it. I'm going to move into it. In fact, you know what I'm going to do? I'm going to turn this flat so it's easier to work on. I'm going to make this 90 degrees. Oh, no, the other 90 degrees. How about that? Let's go 180 degrees, or not. How about I click the number? 180 degrees, and I'm going to put you down flat. I'm going to go here, and we're going to make it 0. I'm going to drag my pointer out of the way, because I'm not so sure I'm done with my pointer, but I'm going to claim that I am for now. I'm going to get in this part's face right here. Boom, there we go. I'm going to grab this thing right here, this little beak-like looking thing. So already it looks kind of like a bird, right? I'm going to do a little bit to it. I'm going to change it up. I'm going to, let's move it 90 degrees. Let's rotate it around 90 degrees. Oh, maybe, nope, wrong. 45 degrees. How about that? There we go. Uh-oh. Already it's starting to look like a beak, like a bird. Dun dun dun. So I'm gonna move these to line them up just so I can get the visual effect. There we go. It's starting to look like a beak from the front, and I think that's funny. That like, it makes me chuckle already. So so I go back to get my pointer here. Excuse me. Just like with the face mask. No buttons. No. This is terrible. Who does this? I do it. I'm that guy today. Okay, so if we zoom in here a little bit more, so I can grab things without causing a ruckus. What I mentioned early in this like 20 minutes is the robots are hitting here on this eye, this like eye thing sticking out, right? So robots are hitting there, and that's what's causing the problem. So we need, yeah, the 3D thing. So robots are hitting there, and they're hitting that spot. So we need parts to kind of like have this angle or this ramp on it. That's why we moved this. We we moved this mask, the angle on this mask, so that it had an angle on it, right? So that's gonna kind of like stop things from hitting the eye right here, the bottom of this eye, as I move this right to the edge, and we do the fit thing again. So right to the edge here, you can see that we want things to stop there. So I think I've done a decent job with the standard part here, because the standard part is up really high, right? That's pretty high, right? 20 millimeters, and this thing is 14-ish millimeters. So I mean, that's not bad, right? That's a decent shape, and we're not going to get too caught on it. I could probably leave it just like that, right? That's what I'm thinking. But we want to make it look kind of like a bird. So should I move it up more like this? I think moving it up more like that kind of looks like it. It also like puts it right in the middle. But I need screw holes. I need screw holes to mount this on if we're gonna do this. So I either need to move it up all the way like that and jam it right in there, or I need to pull it down to cover those screw holes like that. So for now, I'm gonna go with those 2 screw holes, and we're gonna leave it just like that. And now I've got to go through the process of cutting the screw holes in it, and this is where we could take all day doing this. We could take hours. I'm gonna line. Oh, they're lined up, so I'm gonna leave it just like that, and say we could take a long time trying to line up some holes, and do all this number, and where do those holes match, and looking at the bottom and saying, oh my gosh, that thing is so far off. Doing this kind of thing like that to line up holes and drag things out. I'm not a big fan of that. So what I'm going to do is I'm going to pull this aside, and I'm going to do something different. I'm going to copy this part just like that, and I'm going to leave it over here. And instead, what I'm going to do is I'm going to take this all apart. Boom! Look at that. So now we have the 3 holes already cut. I can do this and line up my bird. So I'm gonna undo, and I'm gonna put all my parts together. So I'm gonna line my bird up right here, my bird beak, mask, whatever you want to call it. Again, right there. Let's do the align thing. And this is where I'm kind of cheating, because I'm not gonna try to cut the holes in the beak. Excuse me, that's a waste of my time. That's not something I can do. Instead, I'm gonna do this number. I'm gonna take my board, and I'm gonna do that. Now I don't need all 3 holes, so I can remove a hole in the middle. I can remove. I can separate those as shapes and remove the middle one. Then I can cut these 2 holes into my bird. But first, what I think I want to do is I want to join these again right here, group them, and group them on this part just like that, because I want to make 2 larger holes. Oh, I didn't need to do that. I can undo this part. So what I wanted to do was make 2 larger holes that are raised up. Let's get this out of the way, so that my screws have a place to rest. I need the heads of the screws to have a place to rest. So let's come back here again. So check this out. So I've got these screws. I've got these screws right here. In fact, I'm going to bring it over to the zoomed in camera. So I've got these screws right here, right? And what you can see right here is I need the screws to actually like rest, the head of these screws to rest on. Oh, I need the head of these screws to rest on the beak But the bolt part of the screw, the shaft, to actually make it through the hole that I'm gonna cut. So what I'm gonna do is I'm gonna make an extra hole that's bigger so that the head of the screw can get through. And I'm just gonna put the screw back on this bolt, the nut back on the screw so I don't lose it, because I've taken this, I've disassembled it from the robot here. But we're gonna come back and we're gonna make this a little bit bigger. Why won't you let me move it? There we go. So this was, let's take that apart again, because I'm gonna take that measurement right there. That was 4 millimeters. So let's make this, actually 7 millimeters works. I'm gonna go with 7 millimeters. And we're gonna try to set that over it. I'm gonna shrink this down, and what I'm gonna do is I'm gonna lift it up so that it's not all the way on the bottom, so that it's like that. Right there. So now we're going to cut a flat spot out so that the hole sticking out. And now this is even kind of funnier because it's starting to look like those little nostrils on the side of the bird, on the side of the bird part. So I was gonna try to like line these up perfect and do something, you know, with the align tool, but I don't want to move my other parts. So what I'm going to do is I'm going to move this like that so that it looks close to lined up. In fact, I'm going to get the top view right there, and I'm going to move this to two-dimensional view so it's flat, so I can see that it's like right on the middle right there, just like that. Cool. Now I'm going to duplicate that part, and I'm going to move it right over to the other side. Swoop. And I'm going to place that dot in what looks like the center. Let's go there. Cool. All right. Now I'm going to get out of 2D flat perspective view perspective view and go to orthogonal view so I can see this. I'm going to grab these two parts. Just like that. I'm going to join them. I'm going to grab these two parts and join them. I'm going to grab these two parts and join them. Now I'm going to grab the beak, and I'm going to join the beak, what I'm calling the beak. Cool. Check it out. Now it's kind of upside down. Normally the birds have the little nostrils on the other side, on the upside of the nostril, or the beak. But you can see where we've got this little like recessed spot where I can fit things in. And now I want to, I moved that. Now I want to cut this part out. I want to cut this, well, I don't really want to, but I'm going to. So I want this to fit very, very close to the part here. So watch, I'm gonna cut this out. Poof. And now watch the bottom. Why are you not? Oh, Tinkercad is angry. Sometimes Tinkercad does this thing. I'm gonna let it wait. In fact, while it's waiting, I'm gonna come back and talk. Oh, now that I just switched screens, it's coming back. So Tinkercad has, it's a free software, and it does a lot of cool CAD stuff, but it can only do the things in memory that you can do with Google, because it's run in your browser. So when Google doesn't have enough memory to do things really fast, sometimes it looks like Tinkercad it's stuck. It's not. It's waiting for more memory to open up and so that it can do other stuff. And it's a drawback of running the CAD programs in your browser. It's actually a really cool piece of software for free, for generic use, you know, that kind of stuff. And you don't the learning curve is not very steep for using it. So as soon as I mashed the button, it fixed. But I'm going to come back. So here we go. Back here, now you can see that I've got this cutout on the bottom also. So hopefully this thing fits like right up against my beak. Check it out. In fact, we're gonna slide it over here and see how it looks like that, just like that. So I should have this built-in like ledge on the bottom. And let me go get my pointer. I'm gonna go back and get my pointer. Where'd my pointer go? Did I delete? Oh, I deleted my pointer. Oh, boo. So let's get all up in my face here again. And you can see where the holes line up, and it looks like it hits right here. So my only problem with this thing now is how do I 3D print this? Because I made it not flat on the bottom. So I dig the design. I think it's cool. I'm going to come back and look at it again. But as you can see right here, it is not flat on the bottom. So I cannot 3D print this. You see right under here. I can't 3D print this part because it's not sitting on the workspace. It's not sitting on the work plane. And that's a consideration I would have to take into account if I'm like an engineer designing parts for somebody, is how do I make this part? How do I process this part? Washers are easy. You can stamp them out of metal in a massive die press. You can cast them in a cast. There's all different kind of ways to make a washer. It's just a round little disc. Excuse me. But this is a more intricate part. And while you can't stamp this out of a piece of metal the same way you could stamp a washer, there are other ways you can make this, and that's something that mechanical engineers worry about when they're designing like a factory or machines that produce your bolts and nuts and things, like the stuff you buy at Home Depot. An engineer has to figure out how to build the machine that's actually going to make those things. And this is the exact same thing. We've just built a product as an example. So this product is super cool, and it's very functional. It's got this lip here on the bottom to add a little strength and make sure that it locks together with the part we're working with. But maybe that part is not necessary. Maybe that little lip on the bottom is not necessary, and I take that away. That's a possibility, so that I can print this flat standing up. Another possibility would be printing it on this face, so kind of like turning it, I guess is the right word. Turning it so that it would be flat, like that. It's possible I could print this this way, so that were flat on the bottom. If I move that like that, yeah. So that's another way to look at it. Like, how would I print it that way? I could try to make it flat on the bottom, and this is something I could do easier in my software, my printer software. Cura will let you pick a surface to touch on the bottom. So something like that possibly is another way to print this. You can see I'm not quite on the bottom here, so I could zero that out. And yeah, that's about as close as I'm going to get here. That's another way I could go about printing this, so that I have a flat surface on the bottom. And it looks like if I were to do it that way, I wouldn't have too much to worry about as far as overhangs. I could probably get away with printing this this way, and I'm okay with that too. But yeah, so I'm happy with this product and project the way it is. Like I said, this was 20-25 minutes of making a completely new like beak for this robot. We'll end up making him look like a bird, or her like a bird. I will come back and talk about the part, and I'll say I call the robot him just because there's some psychology behind it. Excuse me. There's a lot of talk today about genders and race and everything else, and I will just say that as a human being, something I learned in civil affairs and psychological operations is that we all have this like inner view of everybody else, and it's not necessarily a you know a bad thing, but it's called a cognitive bias, and everybody has one. And one of those cognitive biases is um, you inside your, like me inside my pea brain, I picture everybody else the same as me, and that comes out in your language. That comes out in the things you say, the way you talk, the words you use. And so when me as a boy talk about the robot here, I project my cognitive bias onto the robot and call it a he. I'll call it a boy. I might call him dumb because sometimes I'm the slow one in the group. Those are jokes. But yeah. So just a little tidbit that it happens. Sometimes you use a word because you hear other people using it. Sometimes it's internal. You closely associate with people who mirror your actions, your words, your thoughts, and you project outward this idea that you believe that other people are like you. I automatically assume some people have this concept of military service because I served in the military. Sometimes I forget that other people didn't. And I forget that it's 1% of America that actually does that. So those are just things that once you have an experience, you sometimes forget that other people don't have that experience, and the same applies to how you feel as about you as a person and all this other stuff. So just my nerdy non-engineering education and experience from thanks to the U.S. Army. But back to this cool robot. We have some super cool parts, and Saturday we're gonna bust stuff up. I'm gonna come back over here. Check it out. So we're gonna have some fences on these eyes. I really hope that's gonna happen. If not, we already know we've got the battery box moved to the back here, and this already is gonna change the way we play because a battery change used to take us 5 minutes, and now it's probably gonna take us 15 seconds. So I'm super pumped and very excited about that, and that alone should really change the whole flow of the matches and the battles. And we're gonna stick with this weekend with a sumo battle again. And I think in March we're gonna change it up a little bit, and we're probably still gonna stick with the sumo battle, but I think we're gonna have a few other surprises, and it's gonna make it fun. We're not advancing to the easy, medium, hard type levels yet, but we're adding some new players. And on that note, that's where I'm gonna mash the end stream button and go find a snack before bedtime. You're not supposed to do that.